Hi everyone, my name is Itzel and my partner is Carlos, and we will be testing to see if the balloons expand with Alka-Seltzer and Pop Rocks added in bottles of soda. We will do the demonstration first, watch and observe what happens, compare and contrast both bottles, and explain how and why it happened. The materials that are needed or that we used is 2 plastic bottles of soda. We used Coca-Cola for one of the bottles and mineral water for the other bottle. We also used Alka-Seltzer and Pop Rocks, and lastly 2 balloons. The instructions for this demonstration is to number 1, place 2 plastic bottles of soda on a flat surface. Then we will add Alka-Seltzer to one bottle and quickly place a balloon on top of that bottle. Then we will add popping candy or Pop Rocks to the other soda and place a new balloon on top of that bottle. And the last step is to watch how the balloons expand and see which substance makes the balloon expand the most. Before we begin the experiment, the purpose is to demonstrate the types of reactions such as acid-base, chemical, and physical reactions to help a student understand how a substance can change when another substance is added. Here are all the materials gathered to begin the experiment. The first bottle we did was Coca-Cola, and I added Alka-Seltzer to it. There was a quick reaction, so as soon as I put in the balloon, Coca-Cola started filling up the balloon, which caused it to expand. Eventually, there was a lot of weight on the balloon, which caused the Coca-Cola to fall. This is what the balloon looked like after I stood up the bottle again. As we can see, it expanded a lot. Next is the second bottle of soda, which we used mineral water. I applied the Pop Rocks to it, and it immediately started to rise, so I quickly added the balloon. I shaked it a little bit just so the reaction could be faster and the Pop Rocks could go everywhere in the bottle. I stood up the balloon and it actually stayed there, unlike the balloon from the Coca-Cola. It did expand, just not as much as the balloon from the Alka-Seltzer bottle. These were the final results of how much the balloons expanded in each of the bottles. Now we will be explaining how and why the balloons expanded with these substances added. First, I will be talking about how the balloons expanded with Alka-Seltzer. The balloon expanded with Alka-Seltzer because citric acid and sodium bicarbonate are both ingredients in this substance. Alka-Seltzer reacts with an acid to make carbon dioxide gas. When it is dropped into the soda, sodium citrate, water, and carbon dioxide were formed, which created gas bubbles that appeared. An acid-base reaction occurred, which is a type of chemical reaction that is an exchange of 2 or more hydrogen ions. An acid-base reaction occurs when citric acid and sodium bicarbonate are combined, which is what happened in the bottle that made the rubber from the balloon expand. In the image on top, it was the type of acid-base reaction that occurred. So as we can see, it has sodium bicarbonate, citric acid, and sodium ions, citric acid ion, water, and lastly carbon dioxide. And this reaction led to the expansion of the balloon, as we can see in the second picture. Next, I will explain how the balloon expanded with popping candy. When making Pop Rocks, heated candy syrup and carbon dioxide gas are combined under intense pressure. As a result of this, the candy develops small, high-pressure carbon dioxide gas bubbles. We feel these bubbles once we have these Pop Rocks in our mouth. The popping candy breaks down when combined with water, which in this case we use mineral water, which releases carbon dioxide, which fills the empty spaces in the bottle into the balloon, which causes the balloon to expand. One tiny bit of gas is present in each of the tiny Pop Rocks. The carbon dioxide in the sugar causes the balloons to expand. However, inflation cannot only begin with only the candy. Because the soda contains carbon dioxide gas, it will result in the expansion of the balloon. The balloon will expand once the candy has been dissolved into the soda because the carbon dioxide gas has nowhere else to go in the bottle, just the balloon. In the first image, it shows how the soda already has carbon dioxide gas, and then in the second image, the Pop Rocks, the ingredients, it shows how it already is processed with carbon dioxide. So since these two already have carbon dioxide, when you combine the Pop Rocks and the soda, no new gas is created because you're just releasing the gas that's already in the candies and the soda, which is why it's just a physical reaction because they both involve carbon dioxide. Here's an image to help us understand the concept of pressure. So as we can see, when the bottle is closed with the lid, the pressure stays inside of the carbonated drink. However, when the lid is removed and the bottle is open, the pressure releases and there's bubbles that appear. we see these bubbles in the drinks that we used, and when we applied the substances such as Alka-Seltzer and the popping candy, this caused the bubbles to rise even more because there was more pressure being added. However, since the balloon was covering the bottle, like the lid, the pressure wasn't able to be released, which is why the balloon expanded, because the carbon dioxide gas had nowhere else to go in the bottle except the balloon. So why did the balloon with Alka-Seltzer expand more? The balloon expanded more because of the increase in pressure from the gas inside the balloon, and because the carbon dioxide being produced is trapped and has nowhere to go, therefore it goes to the balloon and makes it expand. Alka-Seltzer seemed to produce more carbon dioxide than the Pop Rocks did. Thank you for watching. This concludes our video.